This idea that we should prefer heavier flows brings us to the scaling algorithm. One idea is to find the heaviest possible flow. We could do this by starting with an empty graph and then adding an edge with the largest remaining residual capacity until there was an ST path. But this would be unnecessarily slow. Instead, we fix a schedule of thresholds for the residual capacity and lower the threshold when there are no more augmenting paths in the residual network. We'll start by defining the residual network with threshold delta to include only those edges whose capacities is at least delta. Note that when delta is equal to 1, this is the same as our traditional definition for a residual network. We can state the algorithm as follows. We initialize the flow to 0 and the parameter delta to be the largest capacity coming out of the source. This is a trivial upper bound on the value of a single path flow. Then, while delta is at least 1, we look for an augmenting path in the residual graph with threshold delta, and we use this path to augment the flow. Once all such paths are exhausted, we then cut delta in half and repeat. Some of the analysis we can do just by inspection. Letting c be the initial value for delta, it's clear that we only use log c iterations of the outer loop, since we're cutting delta in half each time. And the steps of the innermost loop here, finding a path and using p to augment the path, are certainly order e. The big question then is, how many iterations of the inner loop are there?